Goed, welkom allemaal. Deze sessie. Ik wil met jullie gaan hebben over hoe je microservices kan bouwen met .NET Core en Docker. Er zijn best wel een aantal onderwerpen in één sessie. En we gaan even kijken of we ons daar doorheen kunnen worstelen de komende tijd. Ik ben Edwin van Wijk, ik ben architect bij Infosupport. Exactly, I'm going to do it in English. Thanks for reminding me. Yes. So, let's rewind that. My name is Edwin van Wijk. I work as a principal architect at Infosupport. And I'm going to tell you something about building microservices with Docker and .NET Core. What a great audience. Thank you. First of all, this is what the session is going to look like. I'm going to do a short introduction of .NET Core because there's a lot of .NET Core stuff out there. So I just assume that you know a bit what .NET Core is. Then I'm doing a little introduction of Docker. Do a little introduction of what I think microservices are, because there's lots of definitions out there. And then we're going to dive into code, because I have less slides and more code. I hope you guys like that. And if you want to have discussions or questions in between, just do that. So first of all, .NET Core. What is .NET Core? Well, basically it is .NET, as we all know and love. But it's a new implementation that is also cross-platform. So you can run it on Windows, Mac OS, or on Linux. It is open source, which I think is very important. It's a .NET Foundation project, so you can all contribute. And we've done that with a couple of colleagues not so long ago, and it's very cool. You get a lot of help from the teams, and it's really nice to be contributing to a project like this. It is very flexible, and that's where, in my opinion, the power of .NET Core is. You can just run it in a folder. You can have multiple versions next to each other, and that's different from the way we know .NET, because that was, well, tightly coupled to the Windows and stuff like that, and you could have only one version on a machine, and now you can have a version of .NET in every subfolder for your own application. And that makes it very cloud friendly, so you can have multiple applications on one server, but also very container friendly, as we will see in just a moment. And then there's Visual Studio and command line tooling, as we know from Microsoft. So the Visual Studio is just, Visual Studio as we know it, and you can just build .NET Core application. And the command line tooling is a bit different, and that's also where the power of .NET Core lies. Because if you have .NET Core installed on your machine, you have the .NET command, and you can say, okay, what kind of version am I running? So in this case, I'm running 2.0. That is the latest major version that came out. And you can say, for instance, .NET new, and then you can create all kinds of projects. You can just create an ASP.NET project or a console application. And the way you can build these applications and use these command lines, that also makes it very container friendly, because we can use these command lines in our Docker build files, as we will see in a moment, to create our applications and build our applications and build a container from that. I will show you that in a minute. That's what .NET Core is. There's lots more, like I said, to tell about that, but this is just an overview. When we look at Docker, what is Docker for kind of technology? Well, basically, if you look at this picture, this is what inspired the people that created Docker, because this is very convenient that all these containers are standardized. So if I'm some kind of a shipping company, I wanted to ship something around the world, I know that when I put it in a container like this, I can put it on a ship like this and let it go to other parts of the world. So actually it is a platform for running lightweight containers on a single machine. And what is important to remember is that a container is not a virtual machine. Like I said, there's lots of stuff out there, documentation of Docker, for instance. But it's actually sharing a part of the underlying OS, and that makes them very lightweight. So you can run multiple containers easily on a machine. And you have high density, as they say, of applications on your hardware. And basically a container can become a method of deployment, and that's what you see when you start looking at microservices. It's very important that you have autonomous parts of your application that you can roll out to your environments, and they need to be autonomous, and they need to have their own release strategy. So what we see more and more is that organizations don't release software to, for instance, an operations unit, but they just create containers, and these containers are put on a certain environment, so your test environment or your production environment. So there are lots of CI, continuous integration and continuous delivery pipelines out there that just create containers. They put them in a registry, and then from the registry, they are deployed onto machines. That's basically what happens. And because this container is described by the developing team, it is always the same. So it is not that your application runs in test, but it doesn't run in production because there's a different version of the .NET framework, or a DBAer logged on to the database and created a couple of extra tables. That's not possible. Everything in the container is the same everywhere. So it runs everywhere where you deploy it. And that's very important. And it's something that we want as developers. We have wanted for years. Then there's something that's called Docker Compose, and that is one of the ways you can compose several containers to form an application. And that is what I want to show you today. And that is, it is running on just my laptop, so this is real development stuff. And then if you look at enterprise scenarios where you want to have lots of machines as a cluster and run several containers on that cluster, then you go to stuff like Docker Swarm or Kubernetes or Azure Server Fabric, for instance. These orchestration layers, they create some kind of an enterprise-wide cluster of machines that can run Docker containers. So that's not the step I'm going to make today. This is just me as a developer developing a microservices application, and I want to run it on my laptop. And what's very important with containers, like I stressed before, it's based on open standards and all the vendors support it. So if you do Docker on Linux, you can use the same commands and the same interfaces as on Windows. And that is very convenient because all your scripts and all your tooling just works the same, and that's very powerful. And as we will see, like I said, if you start using .NET Core with containers, that's very powerful. And what I have done for this application, I've used Linux containers, but you can also do this with Windows containers. There's no difference whatsoever. You just need to base your containers on certain different images. So today we're going to look at .NET Core and Docker working together as a beautiful marriage. So then on the topic of microservices, and I don't know about you guys, but if you ask, a guy in a room, what are microservices? You get lots of different definitions. And my definition is always they are small autonomous services, and they serve a certain purpose. So a container or a microservice has a certain responsibility. It does that very well. And it is small enough, because also the question how big is a microservice is often asked, but it is small enough so that you can replace it easily with a different implementation or with a new version or whatever. So if you cut up your application into several smaller parts, then if you change one of the parts, then the chance that you have to bring down the entire application instead of just the chance that you have to take down the entire application becomes smaller because you can just replace that single microservice. But then other microservices need to be able to cope with that. So you have to design your application around the fact that services can be down because they are in an upgrade scenario. Most of the time with microservices, we see more lightweight communication protocols. So for instance, in the .NET world, we are very accustomed to using WCF and XML and SOAP and those kind of heavy protocols that give you a lot of stuff for free, like security and stuff like that. Well, in the microservices world, you see a lot of RESTful interfaces with just some JSON. That's really lightweight and very easy, but sometimes you need to have some cross-cutting concerns and you have to find a solution for that. So when you start using microservices, think about what you need and then find a solution for that. What we also see with microservices, if done right, is that people can grow towards an event-driven architecture in which they don't do request-response type stuff anymore, but they have some kind of a message broker, and over this message broker they send messages between the services. And if you have that, that's very easy, because then if a service is down, the message broker can keep the message, and when the service comes back up, it can handle the message. So there will be, as they say, temporal decoupling that makes it easier for you to just upgrade individual microservices. Like I said, specialized in only one thing, so, single responsibility. Then Basically, I always say microservices is just an evolution of service-oriented architecture, because a lot of principles that we had with service-oriented architecture also adhere to microservices, are still very important. But in the SOA world, we see lots of big services that do lots of stuff. So for instance, I have here an insurance service, and you can register a policy, which is, well, fine, that's cool. But you can also move the customer because he changed to another city. Or you can handle a payment or change the risk profile. So lots of stuff is put into this service because you want to reuse this over multiple applications. Most of the time in a microservices environment, you see more this type of application. So you have several little parts that do one thing very good. So a risk profile has nothing to do with the address of the user. No, it's only because it's in the investment domain or in the investment context. So you cut up your applications, and they all have their own database. So that's also very important. They have their own state, and they communicate using messages. And this is not a rule. So it is not that if you don't have an application that looks like this or an architecture that looks like this, that you don't do microservices. You can mix and match, but you need to do this wherever it is you see the value in that. And often, because if you look at these databases, what we see in a microservices architecture that's very hard for some people to grasp is that you start duplicating data. And yes, that is not evil. You can do that if done right. So what I always say, you can replicate or cache data from other services, but you always have one service that is the system of record, as we call it. So there's one service that can change that data, and that is the single truth. But if you get an event that says, okay, a customer was registered in the customer service, I can cache that data and use that data when I have to do my work, and I don't have to go to the customer service when, and I can do my work when it's down, for instance. But there's always a single truth within the entire architecture, so that's very important. And if you look at, for instance, a pattern like CQRS that has read models and write models, then you often see that a microservice gets a read model with data from other services and uses that data to do its work. Make sense so far? If there are any questions, just interrupt me and ask. So this is basically my introduction, and I've tried to do that as fast as possible, so I hope this is clear, because we're going to look at code now. I'm going to introduce the case that I used, a sample case, a sample application, and that is built around the garage management system. So we have a garage, and people come in, bring their car, and they service these vehicles. It's completely built on ASP.NET Core and .NET Core. It uses microservices, now all these kinds of stuff. And the code is online on GitHub, so I will give you a link to the GitHub repo later on so you can play with this. I've used RabbitMQ as a message broker. I've used SQL Server on Linux because I can. I'm a Microsoft guy, I use SQL Server, and I had Linux containers. Okay, so why don't I run SQL Server on Linux, and it works like a charm. And it's all containerized using Docker. So that's basically what I've built. If you look at the context, so what is in this domain, so to speak, I have customer management. I need to manage the people that come in and bring their vehicle. I have to manage the vehicles, of course. I have my inventory management because I have products, I have parts that I sell and that I use. And then I have workshop management. And that's basically where I make my money. So I need to be able to keep this up and running all the time, because when people come in, I need to make sure that I can service them. Then I have some invoicing, because when I wouldn't make money. I have some notification logic in there, and I have sales, because I also want to sell parts if people come in and want to buy a single or multiple parts. To keep it simple, I just leave out all the product inventory and sales stuff. So this is what we are left with. We have customer management, we have vehicle management, we have workshop management, notifications, and invoicing. That's basically what we're going to look at now. So please take a mental picture, because I'm going to jump over these domains. I think it's not too complicated. I've kept it very simple because it's about the principles and not the application. And like I said, each microservice each domain defines its own model and events. So for instance, a customer management domain has a customer registered, and it has all kinds of data. And like I said, this is a simple application, so it's not a lot of data, but you could plot this on another domain. And the workshop management microservice is interested in this event, but only the customer ID, the name of the customer and his phone number. Because when I'm working on his car and I need to call him, oh, okay, you only want me to change the front tires, but the rear tires are very bad too. Do you want me to check that? I need his phone number, but I don't need his address because I'm not going to drive to his home or whatever. So you just take the data that you need from the events and from the models for your microservice, and that's the data that you can use. And you know, less is more. So the less data you use from this event, for instance, the smaller the chances that you have to change something when something changes in customer management. You cannot completely eradicate the chance, but it's smaller. So basically, this is my logical solution architecture. I have a web app. It uses 3 APIs: vehicle management service, customer management service, and the workshop management service. I have an invoice service, a notification service, and time service, and an audit log service. And these bottom services are just console applications that I start, and they only communicate over the message broker. No API whatsoever. They're just running and do their stuff. And they react to events that come in through the message broker. The vehicle management service, customer management service are just plain ASP.NET MVC web APIs. Entity framework, SQL Server database. Because that is not where I make my money, it is just commodity. I don't want to do any crazy stuff there. For my workshop management, that's something different. I need that to be up and running 24/7 because that is where I make my money. So I've changed that, and I've used the CQRS pattern. So I have the API that I can use to register maintenance tasks and update maintenance tasks and get information about the people that come in today. And I have an event handler that builds up a read model of all the customer and vehicle information so that even though vehicle and or customer management services is down, I can still do my work. And that's what I'm trying to do here. Like I said, it's a very simple application, but this is the scenario that I want to go through with you. The invoice service reacts to events that when certain maintenance task is done, then it will send an invoice to the customer, and the notification service, when an invoice or when a maintenance task is planned for today, it will send the customer a notification on his phone that he has maintenance planned for today. The audit log service just gets all the messages from the bus and just stores them in a data store for analysis or whatever. And what I've done, I've also created a time service. And this is a very simple service. When I start it, it gets the current date. And whenever I roll over to a next day, it will issue an event, day has passed. And this makes it very easy for me to test a functionality like, for instance, the notifications. Because when a day has passed, it looks in the database, do I have maintenance job for today? Because the day has passed. And if so, I will send notifications to the customer for that. And by doing this, instead of relying, for instance, on the system time on my machine, I can easily test those kinds of scenarios. And I will show you in a minute. That's it, no more slides. Now it's code. If I'm going too fast or something is not clear, just let me know and I will dive into that. So first of all, I will show you the solution. In this case, this is purely for convenience. I've put everything into one Visual Studio solution. But every project in here is autonomous, so there are no cross-project references or whatsoever. The only thing that's being reused throughout the entire architecture is infrastructure, and I do this using a NuGet package. So when I build this, I can publish it to a NuGet feed, and when I build my other projects, it gets the infrastructure DLL from the NuGet feed. So you could put this in several different solutions if you would like. I would like to shortly look at the customer management API. Like I said, this is not very complex. It is just a web API. I have a controller, customer management controller. And for instance, when I register a customer, I get a register customer command. It's just a message that comes in. It has the information of the customer that's being entered by the user in the front end, so to say. And then I save it in the database, and using a message publisher, I will show you later, I send a message to the bus. So if you are an architect right now, you're sitting at the front of your seat and you say, ha, and what about transactions and two-phase commit and ACID and all that kind of stuff? Yep, it's not in here. So if I store the customer in the database and something goes wrong when I put my message onto the bus, yeah, I have an inconsistent state. So that is stuff that you need to think about when you build something like this. Because I want to focus on the .NET Core and Docker part, I haven't built all that kind of stuff. I haven't built excessive, there are some in it, but I haven't built excessive error handling. What I did do, for instance, was some retry error. So sometimes I've used Poly. I don't know if you know Poly, but that's a framework that you can use to say, okay, I want you to execute this, and if it fails 3 times, then give me an exception, but retry it. So, and that is necessary for me to be able to cope with services being offline or something like that. So that's in there somewhere. But this is basically as far as it gets for the customer service. And if I start the application in a minute, then you will see that this is just a plain old API. So where's the Docker part in it? Because this is just .NET Core, nothing fancy. But in the solution or in the project, I have a Docker file. And this is very interesting. Because Docker works with a definition file in which I say, okay, I want to build a new Docker image. And from a Docker image, I can run containers. That's important to make the distinction. So my image is kind of a template for containers that I can run. In this case, I say, give me an image that is based on the ASP.NET Core 2.0 image. That's something that's up in the Docker Hub. That's a public registry. This is supported by Microsoft. And this is an image which contains the .NET Core SDK. And there's a little trick that I do because I say, okay, I want to name that my build environment. Because if you think about containers, you want to be as light as possible. So if I roll out my application, I don't want it to contain the entire .NET SDK. That's not necessary. It only needs the runtime. So what I do is, I build my application in the build env that is based on this image. So I copy my CS profile, that is the file that contains the definition of my project. I copy the local NuGet folder. This is the trick, like I said, the infrastructure package is copied into the container. And then I do a .NET restore, which will restore all the NuGet packages. Also the ones coming from the public feed and the ones coming from my, my local NuGet feed. Then I copy all the output and I do a publish. And this command in .NET Core will create a DLL. So it will actually compile the stuff and create a release build in this case, because I use the release configuration and I put the output in the out folder. And then I have my compiled and created application. Then I create a new image based on ASP.NET Core 2.0. This is only contains the .NET runtime, so not the SDK. I copy everything from build environment out folder to my local container or to my local environment. I expose a port because this is an API. I need to expose this customer management API on port 5100 in this case. I say that this is the URL that it needs to use. And then I say my entry point for my container when I run it is the .NET command, and I pass in the DLL that I just created. Crystal clear? All with me. So what I've now done, if I run a Docker command and I build this, so in every project there's a rebuild Docker image, and this is the command that you get. So you say Docker build, and I give it a tag in this case, so you can tag every image that you create with a name, in this case pit stop, the name of the application, customer management API, and I always overwrite the latest. This is a choice. I could always use 1.0, 1.1, 2.0, and that is very, if you look at release management and stuff like that, you can version an image, and that's really, really practical, because if you upgrade an image to production, you can always get that version back, for instance, for troubleshooting in another environment. So that's very important. But in this case, it's always the latest. And if I execute this command, I won't do it now because it will show you stuff of a bunch of logging, and that's not very important. But I will remain with a couple of images on my machine. So if you look here, pitstop/customer management API latest, that is the image. And I could now spin up with Docker run. I could just say, okay, run this image, and it will then start a container, hit the entry point, so it will say .NET with the DLL, and then an application will be started. Make sense? I won't show you that because it's very simple, because it becomes very interesting if I look at the other projects in here. So we will look at the code later on, but for now I want to divert your attention to my Docker Compose file. And this is where it becomes interesting. So imagine that I have done what I've just showed you for the customer management API. I've done that for all these services within my architecture. So I have all kinds of images on my machine, as you can see here. I have the web app, I have the invoice service, I have the vehicle management API, whatever. I have my RabbitMQ. So if you look back at the picture, the broker that I had in between is just a default Docker image from the Docker Hub, created by the makers of RabbitMQ. They've created the default Linux Docker container. I can just pull it down, say Docker run with some environment variables, and I have a message broker. Nothing is installed on my laptop. It is just a Docker container. The same for the Microsoft SQL Server for Linux image. It's just a default image. I haven't done anything. This is, for instance, a development mail server I use to make sure that I can send SMTP mail and then I can look at it. So it's just a test tool. These are all default images in the Docker Hub. And also, if I see this, the ASP.NET Core build and ASP.NET Core images, because I based my images on that. So Docker has a layered, it's kind of a layered technology that layers all kinds of stuff on top of each other. So if we look at this YAML file, because bear with me, this is what it's all about. I can just define my application. So I say, okay, what's in your application? I have several services. This is a standard format. It's a YAML format. And I say, I have a server named SQL Server. It is based on this Docker image. And if it's not on my machine, it will automatically pull it down from the Docker Hub or the registry that I have defined. So that could also be a private registry within my company. I do something with volumes, won't go into that now. I expose a port. This is fairly important for a SQL Server. For those guys who know SQL Server, this is the port. I set some environment variables, like for instance, what is the type of instance I want to run, and for instance, the SA password. So every Docker container or every Docker image has a documentation file that tells you exactly what you need to configure each time you start it. So in this case, I need to pass in the SA password. And from my services, I log on with this SA password. This is not what I would do in production. But for this sample application, I think it's fine. But you could also create a script that creates users with their own passwords. The same with the RabbitMQ. I just started RabbitMQ based on this image. There's also management in it. I will show you in a minute. And etc., etc. And what is very important in this case is that when I start this up in a minute, I do Docker Compose up, that is the command, it will start all these services, which is cool. Not get you very excited yet. But the nice thing is that Docker Compose creates a network for me, a virtual network, and it creates DNS entries, or it, in some way, it makes sure that I can find all these services, all these hosts, because I'm actually spinning up hosts, every container is a host, by the name that I define within this YAML file. So if I look at, for instance, the vehicle management API, this depends on RabbitMQ and SQL Server, and it has a link with RabbitMQ and SQL Server. And if I want to send a message to my RabbitMQ, for instance, on my production environment from the vehicle management API, if I open this, go to the settings and go to production, then I can see that, for instance, the host for RabbitMQ is just RabbitMQ, just as I defined in the YAML file. SQL Server is just SQL Server. And this gives me the opportunity to spin up several services and they find each other instantly. I don't have to do anything about that. If you want to be really tough and raw and you want to do all things with network segmentation and stuff like that, it's all in there. You can configure it. You can do, well, crazy stuff, but I don't need it because I just want some services that can find each other. So by defining this Docker Compose file like this, and this is the big trick. Now you guys need to do, I just say Docker Compose because I'm in, let me show you. I'm in the folder, the root of my solution where the Docker Compose file is. I say Docker Compose, compose up, and it starts doing stuff. And it starts running all kinds of services. Oh, you guys are great. What is it? It's 6:45, and you guys do what I say. It's awesome. I've run this now in kind of interactive mode in the foreground, so I see all kinds of logging because, yeah, hey, this is a cool demo. But you can also do it in the background, and it just spins it up in the background and doesn't bother you with any logging. So what has happened now on my machine, I'm running Docker Community Edition on my Windows 10 laptop. It has spun up all these services, all these Docker containers, and now I have an application running on my machine. So what I could do, I know that my, for instance, my, I guess this is 5100, localhost 5100, my customer management API runs. And because Docker also makes these services, because I've exposed ports to the outside world from my container, I can just do localhost 5100 and it will hit my container, hit my web API. So if I go to the API documentation for this one, I used Swashbuckle, very cool framework to create Swagger. That's the description of my service, API customers, and I can just call this API. I don't have any customers yet because it's empty. My databases are all empty. What happened in the back, because SQL Server was started, I always create my microservice application that when I start it the first time, my databases are created automatically. So I don't have database scripts or whatever. I just do it from the code. So if I look at my database, you have to believe me that there was no database before I did this, but all the databases are created. They're empty, but they're created automatically. This is why, for instance, the first time that I run a service that hits a database, it could be that the database has not been created yet. So I build in a retry. I say, okay, go to my database. If you can't make it to create the database, because, for instance, even my SQL Server could still be starting in the background, I just say, okay, if you get an exception, wait 5 seconds and try again. Do that for 10 times, and if it didn't make it then something is terribly wrong, and just rethrow the exception and it will end. So that's something that's in here. If I go to, for instance, my web API, of my web application, it runs on 6000. This is my web application. And if I say, okay, go to customer management, register a new customer, well, Edwin, address, well, blah, 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 you get the idea. You see there's no validation whatsoever in here. This is not a production environment. Register. It creates the user. So in the back, I call my customer management API. I say register customer. It throws it in the database, and it sends an event over the bus. So if I look at my RabbitMQ, I go to localhost, and I log on to it. So it runs in containers on my machine. I can see that there was a message that was sent. And I send it to an exchange within RabbitMQ, and it gets broadcast to all the queues that I've created. These are also created from the software. So when I start a server, it just creates the queue, and it just got the message. If I now go to the database, something nice happens, because in my customer management database, and this is something that you won't be very excited about, a customer is being created. Yeah, so this is the data. But because when I did that, also an event was sent through the bus, if I look, for instance, at my workshop management database, there's also a customer table. And it has the same entry, but then only the name and the telephone number, just as I said. So it picks up the event. It only takes the fields that it needs. It is just a bunch of JSON that's being sent. It's really, really easy. And it just ignores all the stuff that it doesn't need, and it puts this data in the database. And if I now, for instance, shut down the customer database, I can still create a management task for this customer because I have the data locally. And that's where the trick is. So for instance, what I could do now is, let me show you, I will add a vehicle. You probably get the idea. Register a vehicle. It's Mazda, whatever. Register. Same thing happens. So the vehicle is registered, event is broadcast, and everything that wants to know about the vehicle is notified. So now I can schedule maintenance for this car. For instance, today between 8 and 10, that was this morning, but bear with me, and I want to change the tires for this vehicle. And you see here, I can choose it from a list. And this list came from my workshop management API, from the cache, and not from my vehicle management service, because that could be down. And now I can just register a maintenance job without the vehicle service being online. I could, actually demonstrate that, but bear with me, it actually works. It takes me too much time. So now I have a planned maintenance job for today for Mazda 323. So what I could now do, and let me start my UI for my test mail server. So this is a mail server. It is just doing SMTP, so port 25, and it just, when a message comes in, it shows it in this portal. So that's really cool for doing test work. So what I could now do, and this is also the power that you gain when you use really simple JSON-based messages. What I could do now, I go to my exchange, my pit stop exchange, and I just say, you know what, publish a message for me. I know, because I programmed it like that every message has a message type header with the name of the message. It's just a string. It's not a .NET type or whatever. It's just an indication of what kind of message do I have, so that I'm able to interpret it. In this case, I know it's a day has passed event. And because the intent of this event is completely clear, a day has passed, I don't have to give it any body. It's just an empty object. Yeah, I could, for instance, if I want to make it a more intricate detail, I could say, give me the day that has passed, or something like that. But in this case, it's not necessary. And if you watch this MailDev tab, when I publish this message, it will be picked up by the notification service. And if the demo gods are with me, there should be an email message. But it's not there, so there's something wrong. Maybe my notification service has an unhandled exception. So this is why I do my Docker Compose up in the front, so I can exactly see what's going on. In this case, the specified string is not in the form required for an email address. Oh damn, I should have built validation logic into my front end. Yeah, so this is what went wrong. But because I want to show you this, I will just bear with me. Register. And register a vehicle for this guy. Oh. Let's make it another brand. For the other customer. I will register a maintenance job for him. And now say that a day has passed. I did something wrong again. Probably. Maybe my service went down. Oh, so no retry. Okay. Now you see the power. I can just stop it, restart it, and try it again. So that didn't work really well. But it works. Bear with me. Any questions? Anything you want to see or yes? Because good question. When I stop it, do I also use the database, lose the databases? That was the thing I didn't want to go into, but that's the volume one. Because Docker has a mechanism in which you say, okay, I create a folder in the container, which is actually a volume. And what Docker can do for you is that when from the container something gets put into this folder, it will be put onto the file system of the host. And that's what I've done. So if I look at my YAML file, for instance, I know, for instance, that SQL Server, because your container or your image need to support that. So SQL Server, for instance, I know that it puts its data in /var opt MSSQL within the container. That's in the documentation. So the guy that created the image documented this and created a volume for this. So what I can do, I can create a volume on my machine using Docker volume create with the name SQL Server data. And then Docker will put the data that is being written within the container to this folder onto the volume, and this will end up somewhere on my host file system. So like I said, I just stopped everything, so it's done. I can do Docker Compose up again, so the application is restarted. And then if I go to the database, or even better, I have an application for that. That's why I built the application. If I go to customer management, the customers are still there. So it's just the database survives. My audit log survives. And this is when you start working with Docker, you have to design this. Which data, which logs, for instance, do I want to keep when the container is restarted? And this becomes even more important because one of the principles of microservices is know what's going on. Because you get a lot of these services. You need to know, okay, is my monitoring up and running? Do I know if a service is up? What is going on with the service? When something goes wrong, do I have enough logging to troubleshoot all that stuff? Because that's very important because it's running somewhere. And this becomes even more important when I spin up, for instance, service fabric clusters and I run it on thousands of machines with hundreds of servers or thousands of services. Then it's really important. Now you have to design this when you create the application. So, good question. But the data is still there. Other questions?
How would you synchronize multiple containers that are scaled out?
Yeah.
When you create new containers, how do you synchronize it?
Yeah, very good question.
Event source?
You could, yeah, the question is how do I synchronize all the data between the instances? Because I run now a single instance of my customer management API, but what if I run 10 or 20? Well, in this case, I could just run multiple because it's just a single SQL server that I go to. That's basically what you do. But for instance, if you look at Service Fabric, which is also an environment in which you can run, well, you know, services, but also containers nowadays, it has also stateful services in which the state is replicated over all the nodes. Then you can do stuff like that. So there are multiple solutions. It depends on what you want to do. And, but you need to take that stuff into account. And that's what I always say when you begin with microservices. You can gain a lot because, let me tell you, this is very flexible. I can just bring down services. I can test stuff very easily. But it also comes with a couple of challenges. And you need to make sure that you want to pay for these challenges in order to gain the advantages. And that's, yeah, well, it's just... I'm an architect. It's trade-offs. You need to be. It's no silver bullet. You have to think about that. So, good question. Other questions? Yeah.
You were talking earlier about retries. It seemed as though you didn't really trust the depends on relationships in the Docker compose.
Yeah, I totally trust on it, but because I have.
The question is more, how is that supposed to work? Is Docker compose supposed to take care of that?
No. You create a depends on and you create a link, and it will start these services in a certain order. But Docker Compose does not know how long it takes for the service to start. So for instance, the SQL Server had a lot of stuff to do. It has lots of housekeeping that it has to do. It has to check logs and stuff like that. So sometimes it happens to be that my server is up, my service, and it tries to connect to the database, which isn't there yet. So I need to be able to build retries. And maybe if you allow me, I can show you, let me see, where is it at?
The contract is, yeah, I'm going to attempt to start that service.
Yeah, but it doesn't know what the service is going to do upon startup. So maybe we can do that offline later, but a framework like Poly is really cool for that. And you could use circuit breaker stuff for that. Yeah. You could do that, yeah. But how long should the delay be? Yeah, yeah. So yeah, yes, that is also possible. But in this case, I would really like to be sure and make sure that, because the delay is now actually on the other side. I just delay when when it doesn't work, I delay. When it doesn't work, I delay. But if it works instantly, it's up and running. So, okay. I have a couple of resources for you. This is nearly the end of my talk. Sample code is up here, so you can go to there. I've also created a fairly extensive description of this solution. And although it's very simple and there's lots of stuff that you guys say, oh, you cannot do this in production. Yeah, I know. It's all about the concepts that I try to bring across. So maybe you can look at it, and if you have any feedback or you want to contribute, just do pull requests. And these are a couple of books. These especially. So Microsoft is really busy in this space. Microservices are a big thing, and they've created a great guidance around creating .NET Core applications with containers, for instance, with Service Fabric. So that's really cool. The Building Microservices book is very good. Even if you don't build microservices, there are a lot of great practices in there. And well, I will share the slides later. So without further ado, thank you for your time. And if you want to ask me something, I'm at the info support stand. So thank you.